is about sequences and series, and today we're going to talk about sequences, and when we finish this section we will talk about something called summation notation. Okay, so 12.1 sequences and summation notation, and then by the end of today you'll be able to find certain terms and the nth term of a sequence. And find terms of a recursively defined sequence. And we'll talk about what that is. That's a special type of sequence.
Okay, what defined?
Recursively. Okay, so we're going to find certain terms and the nth term of a sequence, and we're going to find terms of a recursively defined sequence. Okay, so first let's talk about what is a sequence. You've actually had some interactions with sequences when you were in geometry. Sorry, it's a little too snaky for you. Okay, so a sequence is just a function whose domain is the set of natural numbers. Do you guys remember what natural numbers are? You guys know the first natural number? 1. And then it goes 2, 3, 4. So the natural numbers are often referred to as the counting numbers. Because when you start counting, you start with 1, not 0. Okay, so if this were a function, what you'd be finding is you'd be finding f of 1, f of 2, all the way up into f of n. Okay, so what that means is the only thing that you're going to plug into the function are the counting numbers, 1, 2, 3, 4, all the way up into infinity. Now, in a sequence, we use a special notation. The special notation is a sub n. Okay, so we use that. We use this instead of function notation. Okay, so this will be sequential notation, which is different than your function notation. So because we use a sub n, we have these terms in the sequence. Okay, the terms would be a sub 1, a sub 2, a sub 3, all the way up to a sub n. Okay, so a sub 1 is the first term in the sequence. Bless you. This is the second term, and then that would go all the way up into what we call the nth term. Okay, so usually in a function, our input is what variable? just in a normal function. Our input is normally x. Okay, for sequential notation, your input is going to be n. Okay, so that's going to be your input variable. Okay, now in the next one, I asked you to explain the differences between a function and a sequence, and then include in your explanation how the domains affect the graphs. Okay, so the first thing I want you to think about is what we defined up here. So the function has a domain of the set of natural numbers, okay, for a sequence. If it's a function, what is normally your domain for a function? It's a very common one. All real numbers. Okay, so let's think of like a linear function. If you're thinking of a linear function, okay, you might have a line that goes like this. How is that going to be different than if you're only plugging in the counting numbers? There's no zero, and what else? What else is it going to be missing? Yes. What else? Decimal numbers, right? The numbers in between. So if you can only plug in 1 and 2 and 3 and 4, you are going to have unconnected points because they do not include the points in between them. Okay, so this would be a sequence. Okay, so I've crafted a very eloquent response that will encompass everything I want you to know about these. Okay, so the main difference is the domain. For a sequence, bless you, the domain is the set of natural numbers which starts with the number 1 and increases by 1 up to infinity. Okay, so it's important that we know that it's increasing by 1. If you have a linear function or even a quadratic function, you have all of those points in between the natural numbers. Okay, a sequence is not going to contain those points. So a function will include the numbers between the counting numbers in its domain too. Okay, so a function is not only going to include the counting numbers, but it's also going to include the numbers between those counting numbers in its domain. Therefore, a function will be modeled graphically with a line or a curve as a sequence will have a graph of unconnected points. So it's very important that we know those points are going to be unconnected. And hopefully I've modeled for you some good essay techniques for your SAT. We have some good transitions and prepositional phrases in here. Okay, so the function is going to include the numbers between the counting numbers, which means that the function is going to have a graph of a line or a curve, and the sequence is just going to have a graph of points that are not going to be connected, because it's not going to count all those points in between the counting numbers. All right, so for example 1, we're going to find the first 5 terms and the 150th term of the sequence defined by, so we want to find the first 5 terms and the 150th term for the sequence that's defined by a sub n equals 8n minus 2. Okay, so then for a sub 1, if I'm finding the first term is a sub 1. What you're doing is you're plugging in 1 for n. Okay, so then this is just going to be 8 times 1 minus 2, which of course is what? 6. Okay, now I could do the same thing for a sub 2. So 8 times 2 minus 2. So 16 minus 2, which is going to be 14. Now I could continue that. I could do that in my head. Do you guys know another way you could start calculating these next few numbers? Okay, yeah. Why can you just keep adding by 8? What's the significance of it? It's linear, and 8 is your slope. And remember, the slope is the same thing as the rate of change. Okay, so the rate of change from one term to the next is going to be 8. Okay, and really 24 minus 2 is 22, but 14 plus 8 is 22. A sub 4, if you do 22 plus 8, you get 30. A sub 5 would be 38. Okay, so you can use the fact that it's a linear function to find those other two. Now for the 150th, we're just going to plug in 150 for n. Now just like in your past tests and quizzes, you will have a no calculator section. So if we're trying to do this without a calculator, we'd want to do 8 times 15 first. And I would do 4 times 15, because what's 4 times 15? 60. So 60 and 60 would be 120. So 120 with a 0 on the end is what? 1200. So it's 1200 minus 2. Okay, so think of it as 200 minus 2. What's 200 minus 2? 198. So it's 1198. Okay, now before we go on to the next example, we have to see what happens when you have negative 1 to the nth power, okay, because something special is going to happen. So I want you to find the first 5 terms of the sequence given by a sub n equals 5, negative 1 to the nth power. Remember your order of operations. What's going to be my order of operations for this? I have 5 times negative 1 to the nth power. I have to do negative 1 to the nth power before I multiply. Okay, so if I plug in 1, negative 1 to the first power is what? Negative 1 times 5, negative 5. If I plug in 2, negative 1 squared is 1. 1 times 5 is 5. If I plug in 3, negative 1 to the third is negative 1, so that would make this negative 5. If I plug in 4, negative 1 to the 4th is 1, so 1 times 5 would be 5. What do we think a sub 5 is going to be? Negative 5, right? So what effect does this term have on the sequence? And then we're going to explain why that happens. So what's something that we notice here? Okay, yeah, so when you have an odd exponent, it generates a negative term. When you have a, what? Even, it'll generate a positive. And what happens between these? Yeah, they're alternating, right? So the signs will alternate between negative and positive. And then, like some of you mentioned, it says explain why this occurs. So this occurs because of the properties of exponents. An odd exponent produces a negative result for negative 1 to the n. Whereas an even exponent an even exponent produces a positive result. For negative 1 plus n. Okay, so notice how this started on a negative. What if I wanted this to start on positive 5 and go 5, negative 5, 5, negative 5? What would I have to change to this? What's that? Oh yeah, you could do that. Can you guys think of another way that you could change your exponent? Don't make the n negative. What would happen if the n was negative? What does that do? Yeah, because if you had the negative n, well, you'd have a negative exponent is going to make it a fraction, right? So if you had to the negative 2, it would be over that quantity to the second. Think about that. Think about how you could, a different way you could start it, and then we'll come back to it after we do the part that's on the second page. Okay, so we're going to write equations for the nth term of a sequence. So you just found certain terms of the sequence. We found the first 5 terms. We found the 150th term. When you're finding the nth term, what that means is you are going to be finding an equation, and that equation is going to relate the term to the sequence. Okay, so when you're finding the nth term, you're going to be finding the equation that relates the term to the sequence. Okay, so basically what we're going to do here is we're going to start analyzing some patterns. So find the nth term of a sequence whose first several terms are given. Now for A, you have 1, 4, 9, 16. Those numbers should seem familiar. What are they? They're perfect squares, right? So keep in mind that 1 is the first term, 4 is the second term, 9 is the third term, 16 is the fourth term. So what you're asking yourself is, how can I plug in 1 and get an output of 1? How can I plug in 2 and get an output of 4? How can I plug in 3 and get an output of 9? Okay, so what are you doing to each term? Yeah, Sam? Okay, so then if we're going to write this as an equation, we're going to write this as a sub n equals, and then do you guys think you would know how to write it? N squared. Okay, so I thought that would be a good one to warm up with. Okay, now B, we have some fractions. What else do we notice about this pattern? Okay, yeah, so they're alternating between negative and positive. So what is something I could think about including? Negative 1 to the nth power, right? Because that's what we did here. Negative 1 to the nth, that would generate it. Yep. Okay, so sometimes with fractions, I like to look at the numerators and denominators separately. Yeah, Dennis, what do you notice? What's that? Don't tell me the answer. But what is there something that you notice about the denominators? Yep, exactly. Yep. So to get from the first term to the second term, 3 times 3 would be 9. 9 times 3 is 27. 27 times 3 is 81. Okay, so could we write the denominator a certain way? There's actually many different ways you can write this, so I'm going to show you several different ones. So keep in mind that when I plug in 1, I should get 3 on the bottom. When I plug in 2, I should get 9 on the bottom. How could I write an equation for the bottom? Just for the bottom. 3 to the nth. Okay, so if they're multiples, you're going to have to use an exponential equation. Now, because these alternate and because the top is 1, I could just think of it like this. This is going to cause the alternating ones. This is going to give me the denominator. Now, when you check this, make sure that you check it for the sequence that's given. The reason why I suggest that you do that is because 1 and 2 have special properties. 1 can be raised to any power and you'd get 1. 2 times 2 is 4, but 2 plus 2 is 4. So sometimes the first 2 could work, but the third one wouldn't, which is why you want to make sure that you are checking those. Do you guys notice a way I can simplify this? Yeah. Is that how you wrote it, Dennis? Did you write it as negative 1/3 to the n? Or did you do it a different way? You might have done it right. Then you'll have to have, but you still had the 3 on the bottom, right? So you'll have to have the 3 on there. Say it again. Let's try it. Is that what you said, Dennis? Is 3 to the negative n? I thought you said negative 1. Okay, so if you had 3 to the negative n, if you plugged in 1, 3 to the negative 1 would be 1/3. So you'd be close. Okay, so you could do that. Let's see. Okay, so if you made this negative 3 to the negative 1, then you'd have 1 over negative 1/3. Negative 3 to the negative 2 would be 1 over negative 3 squared, which would be 1 over 9. Let's try one more. 1 over negative 3 to the third, which would be negative 1 over 27. That would work. Do you guys thinking of something else? Could some of you do 1 over negative 3 to the n? Which is really the same thing as this, right? Because if you have a negative exponent, it's just 1 over whatever it is positive. Okay, so those are all different ways that you could write the same thing. And I would count any of them correct. Okay. All right, what are some things we notice about C right away? Okay, yeah, so the bottom keeps on being multiplied by 2. So really, could we say what the denominator is going to equal? 2 to the n. So make sure you guys make it clear whether it's 2 to the nth power or 2 times n, because those are going to be different. And that's what I mean about how when you plug them in, because, oops, when you do, when you do 2n, if you plugged in 1 times 2 is 2. If you plugged in 2 times 2 is 4. But when you plug in 3 times 2 is 6. So that's why I'm saying you have to at least plug it into your 3 there. Okay, so that's how we got the bottom. Let's think about how we're going to get the top. What's happening on the top? Yep, it's going up by 1 and starting at 3. So remember, what are you plugging in to get the 3? 1. Okay, so you're going from 1 to 3, 2 to 4, 3 to 5, 4 to 6, 5 to 7, 6 to 8. With all of them, what are you doing?
N plus 2.
Yeah, you're just adding 2. So you can write it as n plus 2. And again, just be careful and make sure that you check. Okay, because sometimes maybe this one's going up by 2, but maybe this is going up by a different factor. Okay. Do you guys remember in Algebra 2 how you would find whether or not functions were like linear or quadratic? The first differences were the same if it was linear, but if it was quadratic, what was the same? The second differences. Okay, so you might have to play around with that for some of the tougher ones. Okay, now we're going to learn about something that is called a recursively defined sequence. Okay, so this is a special type of sequence. The definition is this is a sequence whose nth term depends on the terms preceding it. Okay, so it's a sequence whose nth term depends on the terms preceding it. Okay, so basically it depends on the terms that come before it in the sequence. So there is a special notation for that. So the previous term notation is a sub n minus 1. So a sub n minus 1. So I want you to just think about why that makes sense. Okay, let's pick a number for n. What do you guys want to pick? 6. Okay, now if you were to find n minus 1, okay, 6 minus 1 is what? 5. See how that's the number before it? Okay, that's where it comes from, right? So if you have a sub n minus 1 is the number before it. If you wanted to use the number after it, you would write what? N plus 1. Okay, so for that one on the first page, how I was asking you, how could you get this to start with a positive? What I wanted you to think about is how, if you had 5 to the negative 1, n plus 1, would change it. Because now if you plug in 1 for n, 1 plus 1 is what? 2. So it's even. So if it's even, it would be a positive. And if you plugged in the second term, plus 1 would give you an odd number, which would make it negative. So that's another way that you could change that if you wanted it to start with a positive and then alternate. Okay, so that's something else to think about when you have to find your nth terms. So as we look at the next example, we're finding the first 5 terms of the given recursively defined sequence. There are a couple of things that should stick out right away that let you know this is a recursively defined sequence. What's the first thing probably? Yeah, I would say the n minus 1, right? So if you have the n minus 1, that's going to show you that it's recursive. Well, if I was trying to find the first term and I plugged in 1 for n, 1 minus 1 is what? 0. You'd have a sub 0, which we wouldn't be able to find. Okay? That's why when you have a recursively defined sequence, you're also going to have a term defined, or else you wouldn't be able to find the other ones. So when it tells you to find the first 5 terms of the sequence, it actually already gives you the first one. Okay, so the first one is a sub 1 is equal to 4. Now if you're going to find a sub 2, the first time I am going to just write this out so you can see where this comes from. This is going to be 2 times a to the 2 minus 1 plus 5. But if you have 2 minus 1, that's really just what? It's just a sub 1 plus 5. Right, which we already know. So now you're just going to substitute. So for a plus 1, you're going to plug in 4. And then you're just going to follow your order of operations. So 4 plus 5 is 9. 9 times 2 is 18. So a sub 2 is going to be 18. Okay, so we don't have to write all of that out all the time. But for the next one, so you can just think of this as 2 times, and it's the previous term. So what's the term in front of a sub 3? A sub 2. So it's a sub 2 plus 5. Okay, so a sub 2 we just found was 18. So 18 plus 5 is 23. 2 times 23 is 46. Okay, so try to find a sub 4 and a sub 5. Okay, so for a sub 4, you're adding 46 plus 5. Multiplying that by 2, what do you get for a sub 4? 102. Okay, and I'm just going to write that your a sub 3. And then for a sub 5, it's 2 times 102 plus 5. 102 plus 5 is what? 107 times 2, 214. Okay, and that's your a sub 4. What questions do you guys have for me on the recursively defined sequence? Okay, so then for B, it says find the 20th and the 100th term of the recursively defined sequence. And that does not sound like fun because I have to know what the previous term is, right? Okay, so I'm going to show you how you can use your graphing calculator to generate terms from a recursively defined sequence when they are larger numbers.
What's for lunch today?
Pardon?
You know what's for lunch?
I do not.
Chicken what?
Okay, let's stay focused, please.
Chicken.
Oh. I do not. I feel like, oh, because that, yeah, so I was going to remind you too, if you're taking the SAT, if you do have one that's battery powered, I would bring extra batteries. I know a lot of you now have ones that are chargeable. I would bring an extra one, even if it's just a scientific one, just in case the power goes out. Okay, so a scientific one really is all you would need.
Power goes out.
No, I mean on your calculator.
Oh.
Yeah.
I was like, this thing is really insane.
I'll bring some candles for you.
What?
We'll keep going. I said I'll bring some candles so we can keep going.
Wait, are you proctoring?
Yeah.
That's.
How
long does it take for it to be done?
I don't know. Let's focus on this.
Just answer it.
Okay, so for find the 20th and 100th term, I'm actually going to write down the directions first because this is not something that's just simple to remember. Okay, so the first thing that we're going to do is we're going to put our mode in sequential mode. Okay, so if you go to the mode, you're probably in function. You're just going to arrow over to sequential, which is SEQ, and then press enter. Okay, then what we're going to do is go to y equals. Now when you press y equals, you're going to see some things that you haven't seen before. Okay, so what we're doing in step 2 is we are defining the function. So the first thing it asks you for is, it says n min, which means what is your minimum n value? So think about our domain. What number are we always starting with here? 1. Okay, so in almost all cases, your n minimum is going to be 1. This represents where your sequence starts. So where sequence starts, and that is usually 1, which is why it already has 1 in my calculator. And it should have that for yours too. Now after that, it says u of n. U of n is your equation. So what we're going to be putting into u of n is whatever your equation is. And I'm just going to write out what that was for you again. So a sub n equals 2 times a sub n minus 1 plus 5. And I'm going to show you how to put that in your calculator in the proper way. Okay, so when you're entering it into your calculator, you're going to do 2, and then in parentheses, you'll have a lowercase u. Which is above the button 7. So you're going to go to second, and then you're going to push the 7 button. Okay, and we'll do that in a second together. And then you're going to have another set of parentheses as n minus 1. Now this n is your variable. So remember, we're going to use the variable key. The variable key is the one that has x, t, theta, and n. So see how now we're in the last sequence mode? And that's why this is going to be our variable. Okay, so function notation, parametric, polar, sequential. And then we have the plus 5, and we'll close off the equation. All right, so let's go ahead and let's put that in. So 2, and then parentheses. So this is telling your calculator that this is your recursive function. So I'm going to go to second u, which is above the 7. And then in parentheses, n minus 1. Okay, and then I have plus 5, close my parentheses. Okay, and then notice I have one more thing before it starts with the next one. You can tell it's the next one because see how this one is V now? It goes U, V, W. Okay, so this says U of N minimum. Okay, so the U of N minimum is going to be 4, and you have to put this in fancy brackets. I'm just going to write out why it is 4. Actually, can you guys tell me? Yeah, okay, so this is the output of A sub 1. So because A sub 1 is equal to 4, we plug in 4 with fancy brackets. Okay, so that is the notation. Now, some of the newer calculators, you don't have U of N minimum. You might just have U of 1. Do some of you just have U of 1? So if you just have U of 1, you can just plug in 4. So it's just telling you that this is the output. Okay, this is the output when N is equal to 1. Or whatever the first term is. In this case, our first term is 1. So we haven't done that yet. So after you put the equation in, the last one is the U of M min. So the fancy brackets are right in front of the, on top of the parentheses. So I'm going to go to second, fancy bracket. And actually with a lot of yours, even if you didn't put it in, like I won't put the other one in. I'll just go to enter and then look, it did it for me. Okay, so a lot of your calculators will do that for you. So if you just put 4, then it'll just change it to the proper notation of your fancy brackets. Okay, of your set. Okay, so nope. Press enter. Now what we're gonna do is we are going to quit this. So second, quit. Okay, so we're gonna go. So this is the third step, is to evaluate. So you're gonna go to second, quit, and then you're gonna do U of 20. And then enter. Okay, so to get the U, so second quit, so you have a blank screen. So you're going to have U of 20, and then you're going to press enter. And so what it's doing is it's evaluating for the 20th term. Sorry, I didn't leave a lot of room on mine. So I'm going to squeeze mine here. So A sub 20 is going to be 7,340,022. Okay, and then let's do the same thing with U of 100. Okay, now if it is in scientific notation, you can just do 2 places after the decimal. So we're going to round this. So A sub 100 is going to be 8.87 times 10 to the 30th power. So don't write E. That's scientific notation. Okay, so that's your A sub 20 and then your A sub 100. Okay, and I wanted to make sure you guys had the instructions because I know that it's not necessarily something that comes natural. All right, and then the last thing we're going to talk about briefly today, which we'll talk about a little bit more on for you guys Thursday, is the most famous recursively defined sequence, which is called the Fibonacci sequence. Did I make you guys watch a video this year that talked about it a little bit? Did we watch one about like Pascal's triangle? Hey, have some of you heard of the Fibonacci sequence?
Yeah.
Okay. Have you guys done any activities with it? You guys know what it's related to? Good, because I want to show you some cool things later. Alright, so the Fibonacci sequence is defined as the following. The Fibonacci gets its own special letters here too. So f sub 1 is the first term, f sub 1 equals 1, and f sub 2 equals 1. The Fibonacci sequence itself is f sub n equals f sub n minus 1 plus f sub n minus 2. What we're going to do together is we're just going to generate some of the other terms of the Fibonacci sequence, and we will write them here. So Fibonacci sequence starts with 1 and 1, because that's your first term and that's your second term. Now, if I plug those in, right, if I want to find the third term, f of n minus 1, what's 3 minus 1? 2. So this would be f sub 2 plus 3 minus 2 is 1. So f sub 2 plus f sub 1 is just 1 plus 1. So the third term is 2. Okay, then to find the next term, the fourth term, what two terms would I add together? F sub 3 and f sub 2. It's the two previous terms. So f sub 3 was 2. 2 plus 1 is 3. So for the next term, you can even look at this, right? What are the two previous terms going to be? 3 and 2. 3 plus 2 is 5. What's my next term going to be? 8. What's my next term going to be? 13. Okay, now, what I'm going to have you do right now, and if you don't finish it, it will be your homework, is I want you to find 2 interesting facts about how the Fibonacci sequence is used and write them below. Okay, so you can either use your own device and the World Wide Web to find some cool things, or there are also some facts in your pre-calculus textbook. Okay, so what's that?